I'm going to go over the examples in the 12.2 PowerPoint of how you enter the data into the calculator. I'm not really solving for anything. I just want to walk you through the steps of how you're going to put the data in the calculator and then transform using logarithms to achieve the linearity, like the linear pattern. So first thing we want to do, obviously, if you're able to, go ahead and clear RAM to start out. And then we want to do stat edit, and we want to put all the lengths, excuse me, in list 1, and then all the weights in list 2. So I'm just going to go through typing that in. Okay, I've got all the links in list 1, so now I'm going to move over and put all the weights in list 2. Okay, once we have them entered, we want to go ahead and look at this scatter plot to see if our original scatter plot appears to be linear. So I'm going to do second y equals. I want to select the first plot, turn it on. We want the type to be the scatter plot. We did put our links in list 1, that's going to be our x variable, and then we put the y's in list 2, that's going to be, or the weight in list 2, that's going to be our y variable. You want to do zoom 9 to get a good graph. As you notice, we do have a curved pattern. So we're not real happy with the linear fit on this one because it does look curved. If I go ahead and run the test, the linear regression test, or the linear regression t-interval, that's going to create our residual plot for us. I just picked interval. I don't think it really matters which one you run. We just need one of them run in order to create the residual. I think I said pattern, but I meant residual list. And so I can go ahead and go look second stat to see if it did recreate it, and you'll see that number 7 is now a residual list. Had I looked before I ran a linear interval, a linear regression interval, or a linear regression test, the number 7 wouldn't even exist. Okay, so now that I have the residual list, I'm going to go back to second y equals, and I want to plot the residuals to see if what I'm seeing in the scatter plot is actually holding true in the residual plot as well. So I'm going to select the first plot again. I want to still do a scatter plot. My x list is going to stay the x values, which is L1, but my y list, we want to change it to the residual. So we're going to do second stat and select number 7, which is the residual list. And then we're going to zoom 9. And so this is just more confirmation, if you will, that the original data was not linear, because you do not want to see a pattern in your residual plot. So I definitely see a U-shaped pattern. So this data is not linear, so we've got to go ahead and try to transform it. The first way that we attempt to transform our data is to take our Y list and take the log of it. And the easiest way to enter the data, instead of having to type it each time, like log of 2 and log of 8 and log of 21, I don't want to have to do that. So I'm going to use the function, the ability of my calculator, and I'm going to tell my calculator to take the log of L2. So go up here to L3, so I just arrowed up, and then our log button's over here. And then to get list 2, I want to do second 2. So it's telling it to take the log of all my y values, and I press enter, and it does fill that in. And so now I want my x list to be L1, and I want my y list to be L3. So I'm going to do second y equals, plots should be on, and then I want to be scatter plot again, but L1 with L3 this time, because that is where I have the log of my y values. Okay, so we want to zoom 9 Take a look at what that looks like. Still has somewhat of a curve to it. Maybe it's linear, I'm not sure. So I want to see the residual. So I'm going to do stat test. And again, it doesn't matter if you do linear regression test or linear regression interval. Either one of them is going to lead us to having a residual list. Oh, and I did mess up. So I just ran it again on L1 and L2, and that's not what I want to do. I want to run this on my new list. So I want to do L1 with L3. So I should have gone ahead and changed that right there. Sorry about that. So going down to Y list, and you want to do second 3 to get L2 there. I'm sorry, to get L3 there. Down to calculate. Okay, so again, the point of me doing all that was I wanted to create a residual list, and so now it should have overwritten the residual list that was in there. So I'm going to do second y equals. We are going to select the first one. We're going to stick with this L1 again, but now we want this new residual list to replace the y list. So I'm going to go second stat, and it's still number 7, but it should be overwritten from the new test that we ran. Okay, so then you zoom 9. And this is what the new residual plot looks like. And it is different than the previous one, but it still has the curve, and I'm not liking that. So I feel like I need to go ahead and take the log of both x and y. So I'm going to go back to my lists again. And over in L4, so I went up to L4, I want to do the log of the x's. And the x's are in list 1. Do log of list 1, press enter, it's going to fill them in for me. So I need to remember, as I'm going back and looking at the scatter plot again, my log x is in L4, my log y is in L3, and that's what I want to graph. That's what I want to look at, the L4 as my x's and the L3 as my y's. So second y equals, selecting the first plot, still in scatter plot. Now my x's are, remember, in L4 because that is where I did the log of list 1. And then my y list is second L3 because that's where I did the log of my y, my y values. Okay, so then I'm going to zoom 9. And that's looking a lot more linear than the other two scatter plots that we looked at, but I'm still not convinced. I do want to go ahead and have the residual plot. So I need to run the test again, but remember that now we're going to run it on L4 as our X and L3 as our Y. Okay, so X list is in L4 and then Y list is still in L3. We want to go down to calculate. Again, we're doing this so that it'll overwrite that old residual list. So now it should be the new residual list. So second y equals, turn it on. We got our scatter plot. We got L4. That is the X that we want, but now we want our Y list to be the residual list. So second stat number 7 fills in that residual list, and then zoom 9. And that's way more scattered. You don't see the U shape, so that is our best fit. Okay, so the very first time that I did a logarithm, I only did it on y. That's called the exponential model. When you actually end up having to do the logarithm on both x and y, it's called the power model. So we would say in this example that the power model is the one that fits it better when you have to do the log of y and the log of x. And we can take a look at running the linear regression test to kind of see what that would look like. So linear regression t-test is f of L4 with L3. That's what we ended up being happy with. And when I calculate it, this is going to be our slope, the A. No, I'm sorry, that's going to be our y-intercept. Our B is our slope. So we talked a lot in class about that the variables are changing up on us. So my algebra background is kicking in there. We need to remember now that B is the slope and A is the y-intercept. So it's different than what we're used to. So that's given to us. Remember, S is the standard deviation of the residuals, which is pretty close to 0, so that's a good thing. R squared is our variation, and R is our correlation. So with this new model, this power model, we have a really strong linear fit, almost very close to 1. So that's how you would work with that example. There's more to it, and we'll see a little bit different way to approach it on the practice worksheet, but I definitely just wanted to practice the calculator stuff with you guys because we won't have a lot of time to spend on it in class. So here's a second example that's also in the PowerPoint. I just pulled the data so we can use it. I'm not even really worried about the scenario. I just want to play with the data. So I'm going to put the distance from the sun as our X, and I'm going to put the period of revolution as my Y. So stat edit, I'm going to put the X's in list 1. So let me just type those in. So I've got my X's as the distance from the sun in list 1. Now I'm going to go over to L2, and I want to put my Y values, which are the period of revolution. And it didn't match up, so what did I do wrong? Let's see, 0.387, 0.7231, 1.524, 5.203, 9.539, 19.191, 30.061. Somehow I just skipped that last one. 39.529, checking the second side there. 1.51, 1.881, 1.862, 29.456, 84. 64. Okay, I think it looks good this time. So I'm going to go second Y equals and take a look at this original scatter plot. So I got to turn it on because I did clear my RAM, so everything kind of got wiped out. Zoom 9, that's looking pretty linear, not too bad. I'm going to run the linear regression test. Again, guys, you can do a linear regression interval or test. It really doesn't matter. You just have to do a linear regression so that it will create the residual. That is what I'm trying to get it to create. So I calculate it. Okay, that's all great and wonderful. So now I should have that residual list in there. So I'm going to go second Y equals, look at the plot. I want to do L1 with the residual. So remember, second stat gets us that residual list at number 7. And then I want to zoom 9 from there. Oh, we got a U shape. That's bad in the residual plot. Okay, so even though that original looked pretty linear to me, the residual plot says no, absolutely not. It is not linear. There's got to be a better fit. So I'm going to go ahead and try the exponential model first. The exponential model is just to take the log of our Y values, and our Y values are in L2. So I'm going to do the log of L2 and fill it in. So now I'm going to graph L1 against L3. So second Y equals, turn it on, L1 with L3 this time. And zoom 9 for graphing. Ooh, that's looking really bad. I almost don't even want to do the residual on it, but I'll just run it really quick. But that is definitely not looking linear in my opinion. So we're going to do linear regression of t-test and just calculate it so we can get that residual list overwritten so we can get our new one. And I did mess up. I messed up just like I did on the first example I did. If you were in class with me, I'd ask you, where did I mess up? And hopefully you can tell me, hey, you have to do L1 with L3 this time. So I'm glad I'm catching my mistakes. But don't make that mistake. You got to do it with the new list we created. Otherwise, it's not going to overwrite the residual list because it's exactly the same. So now it should overwrite the residual list with the new linear regression that we ran. So second Y equals, turn it on. I want to do L1 with the residual list. And so we're going to do second stat, number 7. And zoom 9. Man, we got a lot of curve in that. So I'm feeling like the exponential model is not going to fit this. So we're going to try the power model. So remember that the power model is when we take the log of the x variable as well. So I'm going up to L4. I'm going to do log of list 1 because that is where my x variables are. And so I want to graph L4 as my x list and L3 as my y list. So second Y equals, let's go L4, L3 down here. And then we're going to zoom 9. Looking pretty good. Let's get that residual plot. So remember that you do have to run the test to get it to create the residuals. And let's hope that I run the right test or the right list this time. So we want to do L4 with L3. Okay, we're looking good there. And then we go down to calculate. And that residual list should have been created now. So second Y equals, We want to do L4 as our X list, but we want to do resid as our Y list. So second stat number 7 and zoom 9. And I still have pattern, you guys. Uh-oh. So I'm not feeling like any of them are a great fit. That bothers me a little bit. But let's go ahead. Let's see. Not sure where to go with that because none of them really looked good. But I will say out of all of the scatter plots we had, L4 with L3 did look the best. And that was when we did the power model as far as like the original scatter plot, not the residual plot. So I felt like that residual plot did have somewhat of a pattern to it, but this is looking very linear. Let me go ahead and I'm just curious. I'm going to run the test. I want to see what um, our R value would be. So L4, L3 to see if we have a pretty high correlation or not. So we've got our test statistic, our p-value, degrees of freedom. Remember your degrees of freedom, it's how many how many points you put in, but -2. So they did used to have 9 planets back in my day. So 9 minus 2 is 7. We have our y-intercept, we have our slope, we have our standard deviation of our residuals, but I wanted to look at the correlation, and so it is very, very, very strong. So I honestly don't have a good reason for you why the residual plot is not perfect, but it's definitely better than the other two that were super U-shaped. I'm going to run it. Oh, I already ran it. L4, L3. I was just kind of worried that I didn't overwrite the residual plot, but I definitely did. So just one more time, not trusting myself. We did do L4 with residual plot, but I'm going to do it again. Second stat, number 7. And just take a look at it again. And that's just, I guess, the least U shape, even though we would sit there and look at this in class and go, no, that's still pretty curved looking. But I guess compared to the other two, it is the best model. So I would go with power model in this situation. Okay, one more to look at just so you feel comfortable putting it in the calculator. Sometimes you're going to have data that's like in these years, and you can put it in as 1971 and all that. If you look at the PowerPoint, though, the graph that comes right after this example, on their x-axis, it says years since 1970. So this date right here would actually have an x value of 1 because it's 1 year since 1970. So I'm going to put it in the calculator that way just to kind of match what's in the PowerPoint. So in my list 1, so stat edit, list 1, I'm going to go do 1, 2, 4, 8. This one would be 12, 15, 19, 23, 97, 99, 30, 33, 34, 36, 38, and then 40. And again, that's because this is how many years it's been since 1970. Hope that makes sense to you. 8, 12, 15. It was nice of them to put this in order for us, because if not, it would have really been challenging for my brain this late Friday afternoon. 33, 34, 36, 38, and then 40 would be that last one. The transistor value, we're just going to put it in the way it is. 2250, 3500. I'm kind of worried that they changed the data. I'm going to go look on the graph to be by thousands or something, and I just missed it. Let's see. Nope, it doesn't look like I missed anything there. It's just the years since 1970, and then they went with just a regular value, even though it has all those zeros. So let me pull it back up and keep going. Okay, so 2250, 2500, 5000. Oh, messed that up. 29,000, 120,000, 275,000, 80,000, 3100, and 3 more zeros. Hope I'm getting all the zeros. And 24, 1, 2, 3, 1, 2, 3, 42, 1, 2, 3, 1, 2, 3, 220, 1, 2, 3, 1, 2, 3, 592, 1, 2, 3, 1, 2, 3, 1700, 1, 2, 3, 1, 2, 3. This is disgusting, I know. 1900, and then 1, 2, 3, 1, 2, 3. 2300, 1, 2, 3, 1, 2, 3. Hopefully I got them all, you guys. Here we go. So we're gonna go, let's see, let's go look at it. Stat second y equals, we want to turn our plot back on since I cleared my RAM. L1, L2 is good, zoom 9. And that is looking ugly. Stat test, linear regression test. Again, why am I doing this? I'm doing this so that it'll create the residual plot. I'm not even using any of the output it's giving me, but I'm doing this so it'll create the residual plot. So now when I go in to stat plot, I can go change the Y list to be resid by going second stat number 7 and zoom 9, and it should be U-shaped-ish, I don't know, kind of. And so we try to do some log stuff. We try to transform this to appear more linear. So we're going to go to L3. We're going to try the exponential log first. So we're going to take the log of our Y values, and then we are going to, let's go ahead and look at it first. Let's try L1 with L3. So that's the X list with the log of the Y list. And zoom 9. Looking pretty linear, then it has a little blip at the end there. Let's get the stat test, linear regression test. Let me pause and think about what I need to write it on. It's not L1 and L2, it's L1 and L3. This will be my first time I did it right from the get-go, yay. Calculate that. And so again, I don't care about the values really. I just want to look at the residual list. So second Y equals. So we're going to do L1 with the residual list that it just created. So second stat number 7. And we want to zoom 9. And that, I don't know what's going on there. It looks kind of crazy. But let's compare it to taking the log of both of them because it's not like a perfect U or anything. It is pretty scattered, but then I'm kind of seeing like curvy. So I'm not quite sure, but let's look and see if the power model is better or if it's worse than that. So we're going to go stat edit. We're going to go to L4 and we're going to do the log of L1 because that's making us take the log of all of our X list. Okay, so we can look at it if you want. L4 with L3. And zoom 9. And that's really looking curved. So I'm guessing that this one's going to have even more pattern when we get that residual plot going. So we're doing L4 with L3 this time. Remember, I'm just running the test so that it will create the residual list. And so then let's graph L4 with the residual list that we just created. Uh-oh. I hope I didn't just mess anything up. I accidentally hit the plus button. We'll see. So zoom 9. And that's super U. So the best model, even though it wasn't beautiful, it wasn't perfect, it still had that little blippy part at the end, was the exponential model on that one. It's when you were just taking the log of the Y and not the log of the X. So that's your kind of calculator stuff you can look at just to see how to enter things and how to run it. And so I would go back probably if I were having to go further investigating in this problem, I would rerun the test on L1 with L3 because that was our best model when we had the X list left alone, but we had our Y list be the log of our original Ys. And so I would calculate that one and take a look at that equation because that's going to be our best fit. And so we'd have our y-intercept, we'd have our slope, we'd look at the standard deviation of the residuals. I'm going to guess we have a pretty good R value here because we have a pretty good linear fit when we did that. So that's what you can do on the calculator to work with the 12.2 stuff.